Okay, Chapter 9, Lesson 2 talks about lines of best fit. So Lesson 1 was about scatter plots and different things you could do with them and the associations and maybe what trends were with a set of data. Now you're going to actually draw a line that models the data the best you can. Okay, so that's what's called a line of best fit, a line that you can draw through data points that best models what the data's trend happens to be. All right, so example 1, refer to the information in the table about the cost of cookies. Construct a scatter plot using the data. So they just plotted these points, 0, 2.59, 1, 281. They plotted those points, all of these data points. It says graph each data point, draw a line that best fits the data. Now, whenever you draw this line, one, it needs to be straight, so you will need to use a ruler. And when you do that, you will need one, not that obviously you're not going to draw a straight line through all of these points, but you need to draw a line that maybe goes through the center of them. All right? So you should have not necessarily that goes through the most points, but that it goes through the center of them, meaning that your data points are about the same amount above and below. Right? So here we've got 4 above or slightly above, we've got 5 below. It went through some of them. So it doesn't have to go through the most, it just needs to model what it looks like. All right, and then we're going to be getting the slope and the y-intercept that goes with that. So let me get that off of here, and let's go down and look at 2. Use the line of best fit to make a conjecture about the cost of cookies in 2013. We've talked about conjecture before, and that's been in a few lessons. Conjecture just means like what's your forecast, what's your thought, what's your hypothesis about what the cookies cost in 2013. So if you were to extend this line, you know, lines go on in both directions forever, but in this case it would start at 0, go in that direction forever. So in 2013, years since 2000, so in 2013, 13 years down the road, what would you say that they cost? Looks like 335 because it's halfway in between 330 and 340, so 335. That's what a line of best fit is. So that way you can tell maybe what will happen at a certain time in the future. All right, I want you to go ahead and pause it and try the got it here at the bottom. Maybe not draw those data points out, but where would you put the line? Where would you put the line? Okay, so we talked about not necessarily going through the most points, but going through the center of the points, going through the center. So I would probably start somewhere in here and draw a line. Now if I had a ruler up here on the smartboard, that would be a little bit straighter. But again, it has to go through the most points, through the center of them, not necessarily the most. You will have about the same number above and below. So draw and assess a line that seems to best represent the data. That's what we did for A. B, use the line of best fit to make a conjecture about the points the driver will score in 2015. So 2015, so come here, years since 1999, we'd actually have to go up 16. Right, years since 1999 would be 16 years. And there we go. So just right around 6,000, maybe a little bit more than 6,000. Again, what I put on here and where my line crosses may be a little bit different from where your line crosses. So there's not going to be one exact answer for this. There's going to be maybe a realm of possibilities. Obviously, if you tell me in 15 years from now that he's going to score 3,000 points, that's not true. If you tell me he's going to score about 10,000, obviously not true. I would probably accept, depending on where your line happens to be, somewhere just above or just below 6,000. Okay, so again, it's all subjective, just depending on what you've got going on with that. Next page. The scatter plot shows the number of cellular service subscribers in the U.S. Write an equation in slope-intercept form. Remember slope-intercept form back from like chapter 3. Y equals mx plus b. So we're going to have to find m is our slope, b is our y-intercept. Okay, so if we have this line right here, we should be able to figure out the slope rather quickly. Our slope formula, y2 minus y1 over x2 minus x1. You don't necessarily have to pick these data points, because remember, these data points, the line doesn't go through all of them. So I would pick ones that my lines actually go through. So my lines actually go through, let's say like 3, 150. Go through that one right there. Now the actual data point's a little bit lower, but that's okay. 3, 150, I don't know, maybe 9, 275. I'm looking for points like right on these little crosshairs. Okay, so 3, 150, 9, 275. So if I take my y2, so I would take 275, supposed to be a 7, 275 minus 150 over x2, which would be 9 minus 3. So I've got 125 divided by 6. Now obviously if you use your calculator, it's not going to come out even. Here we go, 20.83. Weird looking slope. We've never really had a slope that looks like that before, but then again, we've never dealt with scatter plots, lines of best fit. So it's going to look a little bit different. So our slope, 20.83. Now our y-intercept is where it will cross the y, where it will cross the y. So if you look where it will cross the y, so that will give you a general idea, but now you're looking somewhere between 75 and 100. So if we know that our equation is y equals mx plus b, we know our slope is 20.883. B is what we're looking for. Let me leave some room in there for my x. 20.83x plus b, and that will equal y. Now y, we could use any of the points that we used here. Let's just use 3, 150. So 3, 150, and I'm solving for b. That would be my y-intercept. So I've got 3 times, where's my calculator? 20.83 times 3. So I've got 62.49 plus b, and that's 150. So 150, let's clear it off. 150 minus 62.49, 87.51. 87.51. So that would be our b. That is our y-intercept. So scrolling down here. The y-intercept is 85 because the line crosses the y-axis at about the point 0.085. So we found the exact one, which was 87 point whatever it was. They say it's 85. Again, there's going to be a realm of correctness. It could be a little bit above, a little bit below. If you tell me the y-intercept is 40, we're going to have an issue. If you say the y-intercept is 90, again, that'd kind of be pushing the upper limit there, but you need to kind of make your best estimate whenever it comes to things like that. Okay, let's clear this one off. A few more examples here. Use the equation that we just made, y equals 20.83x plus 85, to make a conjecture, to make your hypothesis, draw your conclusion about the number of cellular subscribers in 2015. So 2015 is 16 years after 1999. So make sure that you're not putting a 15 in there, right? Because the graph talked about 1999, so years since 99. So it would be 16 years. You substitute in a 16 for your x, multiply it out. So in 2015, there will be about 418.28 million cellular subscribers. Okay, last one that we can just try this one here together. So if we talk about slope, let me get my pen back here. talk about the slope, maybe the points that it goes through. It looks like it goes through 160 and maybe 465. 465, let's try that. So 160 is a point, 465. So y2 minus y1, 65 minus 60, 4 minus 1. So we've got 5 over 3. 5 over 3 is 1 2/3. 1 2/3. All right, so 1 2/3, so we can leave it like that. And what would be our y-intercept? Now, if I were just looking, and if I could make an educated guess on this, really, this one will be a little bit easier with this. We don't even have to work all of it out completely. If we know that there's only 5 between 55 and 60, this line is going to go just under 60. What do you think that might be if it's just under 60? I would guess 59. All right, so that would be our y-intercept. So if I had y equals 1 2/3, or I could just leave it as 5/3, x plus, it's plus because that's a positive, 59. So that would be my equation. Use that equation to make a conjecture about the graduation rate in 2020. So notice these are years since 1998. So how many years after 1998 would 2020 be? It would be 22 years, so I would put in a 22 right there. 5/3 times 22 over 1. So that would be 110, multiplying my tops together, 110 over 3. 110 over 3 would be, what, 3 into 110. Oh, how I love this pen. About 36 2/3. And 2/3, even if I wrote this as a decimal, 36 2/3 would be 36.6 repeating. And then it would be plus 59. So 36.6 repeating. Let's just round it off here, 36.7 plus 59 should give me about 95, 96%. 95, 96%. That's where it will be. Now, that would be pretty awesome if that was your graduation rate, but I think reality comes into play there. All right, so with that, you should be good. So try a couple. Again, there's not going to be one exact answer. Things are relative, so as long as you are close and as long as it makes good mathematical sense, you'll be fine. Come see me with questions. Good luck.